Hello calculus students, this is Mr. Myring coming to you with a brief video on the difference between the average rate of change and instantaneous rate of change. So both of these are very important concepts as we enter into our calculus knowledge. From here on out, I may refer to them as AROC versus IROC, obviously. So average rate of change and instantaneous rate of change should make sense. So I like saying AROC versus IROC. So we'll get into this quickly. And we'll talk about it as we look at the AROC versus the IROC. They are very similar to each other. One is what I like to refer to as the old school slope. So it's the same slope you've always worked with since Algebra 1. So old school slope, and then instantaneous rate of change is the hipper, more cool cousin to the old school slope. So it's just a little bit better for us as we work through our calculus understanding. So it's a little hipper, a little better for what we try to do. And so we can kind of get an idea of what it is just with a real basic graph. So here we have a basic graph, points A, or x values A and B. So here you have f of A, f of B if you have some function connecting those two. If you were to do what you've always done and try to find the slope between these 2 points, you would rightfully so want to make a straight line that connects those two. And when you do that, that's when you're working with your average rate of change. So the slope between those two is going to be your average rate of change. So slope between 2 points. Well, with the instantaneous rate of change, what happens then is the reason it's a little bit better is because we acknowledge the fact that not all functions are going to be straight lines, they're not all linear. And so as we think of what other sort of options, all sorts of things could happen between these 2 points. It doesn't have to be this straight line. We drew this green line in order to find the slope. The graph could actually be doing something like this, going up. It could come down and decrease. It could stop for a while, and then it could increase very quickly. So that could actually be what your function is that we're graphing. Well, this green line, the old school slope, still helps us get an average, an idea of what's happening between those 2 points, right? Slope between 2, average, rate of change. So overall, on average, what is the slope? But the instantaneous rate of change wants to look at what's going on at 1 instant, hence instantaneous rate of change. So this would be the slope still, but it's at, so I do capitalize at on purpose there, at 1 point. So at one and only point along here, anywhere, it doesn't matter where it is, it could be here, could be over here, could be right here. You have different slopes at those spots. Obviously this one is increasing, relatively well. At this point the graph is decreasing, and here it is increasing ever so slightly. And so what I'm doing here is drawing in what we call tangent lines, and that's how we find the slope at that spot. And so the instantaneous rate of change is also considered the slope at the tangent line. Slope of the tangent line at 1 point. Let's change that to of. Slope of the tangent line. And what is a tangent line? It is what's going through or going on at 1 point. And so that's what a tangent line is. Whereas then the secant line would be considered the slope for the average rate of change, slope of secant line. And that's what this green line here is actually. When you connect any 2 points along a curve that's not linear, it would be considered a secant line. And so the secant line is going on between 2 points. So tangent line, 1 point, secant line, 2 points. We use that secant line to help us find the average rate of change. Algebraically, you can do your old slope formula, f of b minus f of a all over b minus a. That will become more familiar if it's not already. Or the saying, change in y over change in x. And that's what you guys have heard. Rise over run. All that stuff still counts for slope. That is what your average rate of change is. But instantaneous rate of change is slope at 1 point. And we've never been able to find the slope at one point before, and that's of course the beauty of calculus, and that's what we'll be going with, working towards rather, for the rest of our time together. But this is just a quick video on the difference between your average rate of change and your instantaneous rate of change.